my today's section, and today I am going to discuss about some problem solving sessions on the magnetostatics. And already I have discussed the magnetostatics on the tutorial question bank, some questions. Today I will discuss the remaining questions of the tutorial question bank, the model question paper, and the some gate problems. So let's move to our today's first problem. So today's first problem we will discuss from the problem number 8. A current of 1 ampere is flowing in a circular coil of radius 10 cm and 20 turns, and calculate the intensity of the magnetic field at a distance of 10 centimeters on the axis of the coil and at the center. So there is a circular path where current is flowing 1 ampere, and this radius is given as the 10 centimeter, and its the number of turns is 20. So what is the value of H? H is equal to Ni by 2R. So what is the number of turns? Number of turns is given as the number of turns is 20. Current is given is 1 into 2 into radius. The radius is given as the 10 centimeter. 10 centimeters means 0.1. So we are getting the value is as the 100 ampere turn per meter. So this is the first part. What is the next part? What is the H at a distance of 10 centimeter from the 10 centimeter from the center? So we know H is equal to Ni by R square by 2 R square plus X square of 3 by 2. So if we put the value, what is the value of N? Number of turns. Number of turns is again 20. What is I? I is given as the 1 ampere. What is R? R is given as the R is given as the 10 centimeter. 10 centimeters means 0.1 square by 2 into 0.1 square plus 0.1 square of 3 by 2. If we solve this equation, we will get the value of in the ampere turn per meter. So this is the first part, that a current of 1 ampere is flowing in a circular coil of radius 10 centimeter and 20 turns. Calculate the intensity of the magnetic field at a distance of 10 centimeter on the axis of the coil and at the center. So if we put all the value, we can calculate the value of the H. So this is the little different problem, though the both questions are looking same, but this question is little different. Calculate the magnetic flux density at the center of the current carrying loop. Previously we are using the current carrying loop at the center, so this is also a current carrying loop. We don't want to calculate the intensity due to when current is flowing through a current carrying loop, there will be some magnetic flux, and we have to calculate, and the radius is at the R. The radius is R. So we have to, the loop current is given as the 1 milliampere. So there will be some flux inside. We have to calculate the flux density. We have to calculate the flux density, and loop is placed in air. The loop is given in the air. So how to do this? So first part of this, we will follow the ampere circuit law. What is ampere circuit law tells? When current is flowing in a circular path, then we can write I dl is equal to, current is flowing in a closed path, I dl is the closed path, is equal to h. Sorry. According to the Ampere circuital law, intensity H dl is equal to current flowing in a closed path. So from the Ampere circuital law, we can write H is equal to H integration of dl is equal to I, because for a constant current, the flux density will be always constant. So H is equal to H dot dl is equal to I. So as this is a circular path, we can write H into dl is equal to 2 pi r is equal to I. So what is H? H is equal to I by 2 pi r. Now what will be the flux density? The flux density flux density V is equal to mu into H is equal to mu I by 2 pi r. We will use this formula to solve this problem. So what is the problem? Calculate the magnetic flux density at the center of a current carrying loop when the radius of the loop is 2 cm. So what is the radius value? The radius value is 2 cm is equal to 0.02 meter. What is the value of the current? Current is 1 milliamps. What means 1 into 10 to the power minus 3 amps. And we have to calculate the loop current in 1 ampere, and the loop is placed in air. So mu is equal to mu naught is equal to 4 pi into 10 to the power minus 7. So what is the value of the B? B is equal to mu I by 2 pi r. Mu is equal to mu naught 4 pi into 10 to the power minus 7 into what is the value of I? I is equal to 10 to the power minus 3 by 2 pi into r 0.02. So pi cancel out, it is 2. So 0.02 means 100. So 100 into 10 to the power minus 10, and or we can write 10 to the power minus 8 Tesla. Problem 9. A circular loop located on x square plus y square is equal to 9 and z is equal to 0. So we got one equation carries a direct current of 10 amps along the perimeter. Find the H at 004 and 00 minus 4. So we have to calculate the two things of a problem. A circular loop located on the x square plus y square is equal to 9. So this is a equation of a circle. X square plus y square is equal to 9. So this is an equation of a circle, and in the circle, so x square plus y square is equal to 9 is a circle equation whose origin is at a center. So we got the circle like this. And what is the value of the radius? Radius value is 3. What is the amount of current flowing in this circle? The current is 10 ampere. We have to calculate the value of H is equal to 004 means on the Z axis. 004 means this is a Z axis 004 and minus 0 minus 4. So we have to calculate the two equations. So how to get the value? The value is we can solve this problem by So H is equal to 0, 0, 4 and 0, 0 minus 4. So what is H? H is equal to, first one is the n number of turns I r square by 2 r square plus x square by 3 by 2. So here number of turns is not given. So we will write the number of turns is 1. I is equal to 10. What is the value of r? R is the 3. 3 means r square is the 3 square by 2 r square. 3 square plus 4 square. 3 square plus 4 square is nothing but the 5 square of 3 by 2. So 5 cube. So the value is coming in 10 into 9 by 2 into 5 square means 5 cube. 5 cube is 125 ampere turn per meter. Further, if it is in the minus 4 also, this will be the same, only 0, 0 minus 4. So this is the value of the H. Next, we are moving to the next questions. Two long parallel conduction carrying 100 ampere current. If the conductors are separated by the 200 mm, find the force per meter of each conductor if current is flowing in the opposite direction. So there are two current carrying conductor, each is flowing the 100 ampere, and if they are in the opposite direction, the force is always the repulsive force, and the distance is 200 mm. 200 mm means it is the 0.2 meter. 0.2 meter. So what is the, how we can calculate? We know the force on the, say this is a P and this is Q. So force on the Q conductor, force on Q due to P. So if we want to calculate the force on Q, it will be B1 I2 into L. What is the B1? B1 is the flux due to I1, and this is a circular path. The flux is always going in a circular path, and we get it from the Ampere circuital law. So what is the Ampere circuital law? You get mu I by 2 pi r. Just to show it, the flux in a circular path, if the flux density will be mu I by 2 pi r I2 into L. So what is the force per meter? We have to calculate force per meter. Force per meter is mu I1 I2 by 2 pi r. So what is the value of mu? As this is in the air, it is 4 pi into 10 to the power minus 7. I1 into I2 both are 100 into 100 by, by 2 pi into r. R is the 0.2. Pi cancel out. 2 is there. So we will get it. So 2 into 100 into 100 into 10 to the power minus 7 by 0.2. 0.2 means it is 10. So if we put the value 1, 2, 3, 4, 5, so 10 to the power minus 2 Newton per meter, or 0.01 Newton per meter. This is the force on the equation. This is the force on these two lines. Now we are moving to the problem number 13. Calculate the magnetic flux density at the center of a current carrying conductor when radius of the loop is 2 cm. loop current is 1 milliampere and the loop is placed in the air. The magnitude of the H at a radius of the 1 meter and the value is again find the current in the air. Find the current. So we have to calculate the and the magnitude of the H is 1 meter from a long line conductor of 1 ampere per meter and find the current in the air. So again we will use this equation H dot dl is equal to I enclosed. We are using the ampere circuital law to calculate the current. But what is H dot dl? H dot dl is nothing but the 2 pi rho. Rho is nothing but the radius into H pi. So what is given in this problem? I think there is. Sorry. So we will start the problem number 13. An infinite filament on the Z. So actually. So when the magnetic flux at the center of the 2 centimeter loop current is 1 milliampere is placed in the air. So same type of problem, this is calculate the magnetic flux. So what we got here, H is equal to, from the ampere circuital law, we can write H is equal to I by 2 pi r. So I value is given in the problem. I value is given in the problem. What is the value of the I? I value is given as 1 milliampere. 1 milliampere. What is 2 pi r? 2 pi r. What is the r? R value is given as the R is 2 centimeter. So we will get the value of the H. We have to calculate the magnetic flux density. So what is magnetic flux density? Magnetic flux density is equal to mu into H. What is mu? Mu is it is placed in the air. So it is 4 pi into 10 to the power minus 7 into 10 to the power minus 3 by 2 pi into 0.02. So if we put the value 2 pi is 2. So this value is 100. So it is 100 into 10 to the power minus 7. The magnitude of the H of the radius 1 meter of a long line conductor is 1 ampere. So this is also find the current. So H is equal to Ni per unit meter. Here L is equal to 1. So H is equal to Ni. Long linear conductor means the number of turns is equal to 1. Long linear conductor means that is only long one conductor. So number of turns is equal to 1. So H is equal to I. What is the value of H? H is equal to 1 ampere per meter. So what is the value of I? I is equal to 1 ampere. So this is the answer and this is Tesla. So this is the answer of the problem number 13. Now we will move to the next problem, which is actually the problem number 14. An infinite filament on Z axis carries 10 milliampere in the user direction. Two uniform cylindrical current sheets are also present with magnetic of 300, magnetic means magnetic field, 300 milliampere per meter and 400 milliampere per meter at rho is equal to 1 centimeter and rho is equal to 2 centimeter respectively. Find the magnetic field H phi at rho is equal to 15. So here we will again use the concept of the ampere circuital law, that H dot dl is equal to I enclosed. And if we are thinking about the filament, means this is a cylinder. and this is the another cylinder. What is rho? Rho is 1.5 centimeter. What is I enclosed? I enclosed is equal to 10 milliampere plus 2 pi rho h pi. 10 is plus 2 pi rho h pi. So what is this? 2 pi. What is the value of the rho? Rho value is given here. The 1 centimeter. 1 centimeter is nothing but the 0.01 meter. And what is the h pi? H pi is given as the 300 milliampere per meter. So it is the we got from the I enclosed. So there is already one current is 10. So if we total value is coming as the 28.84 milliampere. So if it is the total flux is 28. This is the actually in the cylinder. So 2 pi, if it is for the rho, find the h pi. 2 pi rho is 0.015, h pi is equal to 28.84 into 10 to the power minus 3. As we know that the field strength is constant throughout the filament. So from here we will get the value of H is equal to 0.306 ampere per meter. We got the equation 0. So we are using the ampere circuital formula. H dot dl is equal to I enclosed, and for a cylinder the dl is nothing but the 2 pi rho. Rho is nothing but the radius of the cylinder. Determine the magnetic field at the center of a semicircular piece of wire with a radius of 0.2 meter. The current carried by the semicircular piece of the wire is 150 ampere. So again we are using the ampere circuital formula. H dot dl is equal to I. So this is a semicircular phase. So current is flowing. And we have to calculate the magnetic field at the center. So what is this? This is the H dl is equal to I. So what is the value of H? We can write H is equal to dl into I. For a semicircle, for a full circle, this is 2 pi r. But for the semicircle, the value is coming as the H is equal to pi r is equal to I. So what is H? H is equal to I by pi into r. What is I? I is nothing but the 150 ampere by 3.14 into radius is 0.2 meter. So if we calculate the formula, we will get the value of the semicircular piece. So up to these are the discussion of all the tutorial question bank and the old question papers and the model question papers. So thank you all, and thank you all. And in my next lecture, I will discuss about some important gate problems also. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.